Okay, gang, on 49, this is tricky again because it looks very similar to being a product, but it's not. This is actually just a composite. And we saw this in another example. So let me remind you that when you have a trig function, you can put all sorts of things in there, including putting another trig function, and that tends to look really weird to us, okay? That's sort of like the idea of a snake eating a snake or a fish eating a fish. Is when something very similar is inside something. When something's inside of something that looks very similar, we don't always recognize it. So some people's brains are going to think that that this is a product, but it's not, because for this to be a product, you actually have to have two different variables. You have to have a sine x times a cosine x, where this is strictly something inside of something else. And as the thing that gets stuffed inside gets enormous, it can look really weird to us. So if this looks really weird to you, that's absolutely normal. Okay, I'm just going to rewrite this now in its fractional equivalent. This is strictly chain. I know it looks a little weird, but the outer layer is the trig. The middle layer is the half, because the half is on the guts. This is the guts right here. This is what's in the trig. The 1/2 is on the guts, not on the trig. And then the innermost part here is what's inside the trig. All right, so I'm going to go ahead with the derivative. So this is the outermost layer. I'm going to take the derivative of this. So derivative of sine is cos, keeping everybody else the same. So I'm going to put a box around this, brackets, because it helps people's eyes. So I just did the sine. So now I'm going to get rid of it. Okay, I did that part. It's gone now. So now I'm on to just this, and on what's left, this is now the outer layer. So I'm doing the power rule. I'm going to bring the 1/2 down. It's going to become a negative 1/2, and then remember, you keep the inside the same. All right, so that's the middle guy. If you're getting this, excellent, excellent, excellent. It does take a little while to see it. If you're still fighting with it, just keep fighting with it. Gumption plays a big role in life, just being able to stick with something and figure it out. Oh, you know what? There's actually 4 layers here, because this is actually the 3rd layer, and inside the 3rd layer is the 4th layer. So I didn't even count this correctly initially. There's 4 layers. So now I'm going to do the cotangent of this inside. Wow, I'm going to run out of room here. I'm going to have to... Wow, this is quite long. This is a 4-layered. All right, derivative cotangent is negative cosecant squared of the inside. Oh, bear with me here. I'll write it better the next time. So 3 pi x. That is the 3rd layer. And then so this guy's now gone, and now the layer, this is 3 pi. So this is 4 layers. 4 layers. Outermost, next layer is the radical, next layer is the cotangent, next layer is the 3 pi x. Holy cow. All right, let my brain just register this. This is wild. This is a really cool problem. All right, let me, wow, my brain's like, how do I even fit this on the piece of paper? All right, let's find all the outsides. 1/2, a negative, and a 3 pi. All right, so let's start with that. So negative 3 pi over 2. All right, now this guy's negative, which means it's going to flip down. And it has a radical on it of a 1/2. So it flips down with the radical on it. This guy's upstairs. This guy's upstairs. All right. Cosecant squared. This should be a 3 pi x, right? 3 pi x. And a cosine cotangent 3 pi x. I'll just shove it back in the radical. It might be less information to look at if I do that. Holy cow. Okay, just to say that clean up one more time. Outside you got a 1/2, a negative, and a 3 pi. So that's the negative, the 3 pi over 2. This guy flips down with a radical on it. This guy I brought to the front. He's right here. And this guy I put in the back. Alright, that's it, folks. That is the big answer. Woo, if you got that, you are golden. That is a nice question. Alright, gang, catch you in another video. Bye-bye.